Hey guys, today we will be solving the Leetcode POTV, that is minimum time visiting all points, right? So on a 2D plane, there are endpoints with integer coordinates points xi and yi, returning the minimum time in seconds to visit all the points in given order, right? So in 1 second, you can either move vertically by 1 unit, can either move horizontally and move diagonally. So square root 2 is basically one down, one right. So basically 1 square plus 1 square is basically the square root of 2, right? It's also written here. Move one unit vertically, then one horizontally in 1 second. You have to visit the points in same order as they are appearing in the array. You're allowed to pass through the points that appear later in the order, but these don't count as visits. So let's see this in whiteboard, right? So these are the points. If you can see clearly, the points are 1 comma 1, 3 comma 4, and minus 1 comma 0. We draw it in a number line, right? Because this is 1. So the first point is this one, 1 comma 1, 2 3, 2 3 4. Yeah. So the second point would be here, and the third point would be here, right? Minus 1 comma 0. Yeah. Now you can see clearly. First, we need to move from this point to this point. It is this to this. Okay. So if you see clearly, we need to go this many to right and this many to left, to top, right? What is this value? This value is actually equal to 4, sorry, 3 minus 1. It is x coordinate of the second one and x coordinate of the first one. Okay, that is 2. So we need to move 2 units this way. Okay. How much we need to move here? So that's basically we need to move 4 minus 1, the y coordinates difference, 3 units. So we need to move 3 units this way, 2 units this way. So let's talk about what are our option of moving. Okay, so from a point you can either move by 1 unit, or we can either move by 1 unit, or we can either go here, right? So all of these three things were done in 1 second. So can you tell me which one is better? So definitely this is better one, right? Because in 1 unit, you can go 1 unit here, 1 unit here. So both of them can be happen at 1 second, right? So here, if you see, instead of going two here, two right and three up, that's causing us 5. What we can do is we can simply, let's draw this. Okay, we need to go 2 units here. We need to go 3 units here. So instead of going 2 here, 3 here, what we can do is for this 2 and for this 2, we can go move directly diagonal, right? So minimum of this 2 we can get. So this becomes a square, right? Because we need to go diagonal. So when we go from here to here, the minimum of this 2, 3 comma 2, that is 2. In 2 seconds, we can reach here. We can reach this 3 comma 2, 3 comma 3, right? To this side in 2 seconds. Then in the remaining second, we can move the remaining one, that is 1. So how much does it cost? 3. And that's the minimum. You can check other cases also. If you can simplify this, can we simplify this more? Let's see. We has to simplify the things as much as we can. So the claim is that we can move 2 right and 2 up in 2 seconds. Then we'll do the remaining part, that is the longest. Suppose let's denote this horizontal distance by A, this vertical distance by B. Okay, so the maximum we can get is A plus B. Totally understand where 2 plus 3, that's 5 is maximum. Now what this strategy, the strategy we just discussed, this tells is we should take the minimum of this A and B. So minimum of A and B, then we should take the maximum of A and B and should reduce the minimum of A and B, because this one is maximum, right? You can see the minimum of this 2 is 2, and then maximum of this 2 is 3, and the remaining part is maximum 3 minus whatever we already covered, that is the minimum. This thing is already covered, right? Can we simplify this equation? Yes, we can. How? See, the minimum is already covered by this thing, right? It already covered. What left is the minimum portion in the maximum. So this is the maximum, right? So in the maximum distance, we already covered the minimum using these steps, minimum number of steps. What remaining is this max. So if you can simplify this is A plus B minus A, right? Because A is the minimum. If you can see, we can eliminate both of them and take B, right? So what we can say is, so distance between 2 points is only because none but the maximum distance between X and Y. So what's the maximum distance? That's 2. What's the maximum distance? 3. So I can say that 3 distance for this to this. Okay. Now similarly, see here. What's the X distance? That's 4, right? 3 minus of minus 1 is 4. What's the Y distance? That's 4. What's the maximum? 4. We got 3 here, we got 4 here. What's the answer? 3 plus 4, 7. And if you can see, that's the answer, 7. Got it? So this is how we can simplify complicated problems and formulas in such a simple manner. Let's just code it up. So we are taking the points, not size. So we will take our answer here. Then what we will do is we can move from first index, because we need to take 2 adjacent points, right? Because we only need to move in a direction. So int x distance. X distance is basically the absolute difference between points of I 0. Zeroth element is x coordinate, right? And we should take the difference with the I plus I minus 1. We got the x distance. Similarly, we can get the y distance by taking the second element, that is, you can see here, this 1, 4, these are the second y distance. And finally we should only add in answer, that should add the maximum of these two. Finally would return the answer. Let's see if it passes. Yeah, it is. Submit this. Yeah, it's passing. As you can see, you can simply do the thing by looking at this. Right. Thank you.